We're basically done with the first law of thermodynamics, but right now let's try to apply those concepts of internal energy and enthalpy and work and heat sa chemical reactions. So this is now the subject of thermochemistry. But before we get to actual chemical reactions and maybe even biochemical reactions, let's discuss some forms of enthalpies na pwede nating ma-encounter sa thermochemistry and thermobiochemistry. So, the first example will be yung tinatawag nating enthalpy of phase change. Okay? So, karaniwan natin itong nakikita. Enthalpy of phase change at 298 Kelvin, which is pretty standard temperature. If you have this change wherein water, and let me use another color here. So we have water in its liquid state changing or undergoing a phase change para maging water in its vapor phase or gaseous phase. Yung enthalpy daw will be equal to a value of 40.66 kilojoules per mole. And by the way, this process is called vaporization. Alright. Ngayon, yung reverse nung process na to, wherein, let's say, you have water, pero nasa gaseous phase siya, forming water na nasa liquid phase. Basically, it's just the opposite of the first phase change na sinulat natin dito kanina. It turns out na ang kanyang enthalpy will have a value of minus 40.66 kilojoules per mole. So, ibig sabihin, opposite lang in sign nung unang reaction. Now, this process is called condensation. Okay. What if ang gagawin natin ay we have water in its solid state, ibig sabihin ice, tapos mag-form tayo ng water sa kanyang liquid state. So, ibig sabihin, tutunawin natin yung ice. So, according to experiments, yung enthalpy daw for this type of phase change is equal to 6.02 kilojoules per mole. And since we are doing melting, so ang tawag dito is melting or fusion. So yung enthalpy, which is 6.02 kilojoules per mole, is called enthalpy of fusion. So yung kanina, enthalpy of condensation, enthalpy of vaporization. Now, let's also do the reverse for this particular reaction. Ibig sabihin, what if water or liquid water forming ice? So, siguro nawalaan nyo na ang kanyang enthalpy will just be opposite in sign dun sa naunang enthalpy. So, yes, this is equivalent to minus 6.02 kilojoules per mole. And we call this the enthalpy of freezing. Alright. Now, what if ang gawin natin is you have water in its solid phase. So, ibig sabihin, ice na naman. Pero, magfo-form tayo ng water na gaseous phase. Okay? And this process, we call it sublimation. Tama? So, whatever the enthalpy na makukuha natin dito will be called enthalpy of sublimation. Now, at certain conditions, pwedeng mangyari yung ice will go to its vapor form directly. Pero, it could also happen na yung solid, dadaan muna siya ng liquid, and then liquid will go to gas. Okay? Ibig sabihin, what we are actually trying to accomplish here is we are adding or taking the sum of this reaction, which is vaporization, in this, no, it's not the reaction, that's just phase change, and this process called fusion. Okay? So if you take a look at these two processes, if you add them, okay, mawawala lang yung liquid because it appears on both sides of the process. So ang matitira is yung ice going to the vapor. Okay, what we will do with the enthalpies of vaporization and enthalpies of fusion, since inad natin yung dalawang equation na to or dalawang process na to, we will therefore also add yung dalawang enthalpies na yan. So, ibig sabihin, yung enthalpy of sublimation will be equal to the enthalpies of vaporization plus the enthalpy of fusion. So that is your enthalpy of sublimation. Now we call this practice or principle as Hess law. Okay? So ang ibig sabihin ni Hess law is that regardless of multiple steps, the total enthalpy is the sum of all changes. So mathematically, yung enthalpy net will be equal to the sum of all enthalpies of all reactions or phase changes or whatever change or process do you have. Okay? Ibig sabihin, kung ano man yung steps necessary to arrive at this net reaction or process, what you will do is just add all enthalpies of all these changes, and the result will be the enthalpy for this sought after process. Hess law ang tawag dyan. So gawin natin din yan doon sa process kung saan meron kang water in its gaseous state or vapor transforming into water na nasa solid state. So ibig sabihin ice. So kung titingnan nyo tong process na ito, it's the sum of these two processes above. This and this. Okay? Yung liquid, it appears on both or on opposite sides of the processes. So ang natira is gas forming the solid water or ice. So ito na yung process na yon. So kung inad natin yung dalawang process na yan, we will also add the two enthalpies, which are the enthalpies of condensation and the enthalpies of freezing. But first, what do you call this process? So we call this phase change as deposition. Therefore, the enthalpy of deposition would be equal to the sum of the enthalpies ni condensation and yung kay freezing. And if you notice, these two processes, si sublimation tsaka deposition, they are opposites. Sublimation is solid to gas and deposition is gas to solid. So kung opposite sila, ang ibig sabihin lang yon is that yung enthalpy nung kay deposition will just be equal in magnitude but opposite in sign ng kay enthalpy of sublimation. What are the other forms of enthalpy that we might encounter? So, if you have, let's say, an atom or an element in its solid or standard state, and you produce the same atom pero nasa gaseous stage na siya, we call that enthalpy of atomization. Kapag mayroon kang solute, tapos ang gagawin mo is you solvate that solute para maging part siya ng isang solution, there's also an enthalpy involved when we call it the enthalpy of solvation. What if you have your chemical reaction wherein your reactants combine to form your products? So, tawag naman doon ay enthalpy of reaction. And you also have the case wherein your elements form your compounds. So, essentially, reaction din yan. It's just that it's a special case kung saan elemental yung nature ng mga reactants mo. So, kunyari, oxygen gas, hydrogen gas. So, we call this enthalpy or change in enthalpy, no? Enthalpy of formation. So, ang tanong na lang dito, paano natin makukuha yung enthalpy? So, remember, enthalpy, the definition is U plus PV, no? Internal energy plus PV work. So, if we take the differential or derivative, magiging dH equals du plus the derivative of PV, right? Now, let's assume, well, for most chemical reactions, constant si pressure. So, if pressure is constant, and let's include also temperature, because certain reactions occur at a certain temperature. So, pressure and temperature, sabihin natin constant. So, since constant si pressure, ang mangyayari sa differential or derivative mo, magiging dH equals du plus pdv na lang siya. So, if you're going to integrate this, yung dH magiging delta H, yung du magiging delta U, constant si pressure, yung dV mo magiging delta V. So, this is another important equation in thermochemistry. Now, let's take it a few steps further. So, if you have a chemical reaction or a biochemical reaction, gawin natin delta H equals delta U plus the constant pressure times delta V. Now, if your reactions include gases, ang gagawin natin is we will use the ideal gas equation solving for V, that will be nRT over P, right? So, Yung delta V, di ba, V2 minus V1 yan. So, delta H equals delta U plus P. Yung V2 magiging N2 RT over P. Wala kang T1 or T2 kasi constant si temperature and ganoon din si pressure. Minus N1 RT over P. So what will happen with this equation? So magiging delta H equals delta U. Makakancel lang si P. Tama? So ang may iwan ay plus delta N, because delta N is N2 minus N1, times RT. And normally, lalagyan natin ng subscript G yung delta N kasi you can only use this if you have your gaseous molecules in your reaction. So this is now how you compute your enthalpy for your reactions at certain temperature and at constant pressure. Ang problema nga lang, how do you exactly determine yung delta U? Right? So sa delta U, paano yan? Saan natin hahanapin yan? Delta NG, RNT, madaling kunin. But si delta U, how? Well, may mas magandang paraan para ma-solve natin si delta H or si change in enthalpy. And that is using yung tinatawag nating thermochemical equations, wherein, let's say you have a reaction A plus B forming C plus D. By the way, for delta NG, I forgot to note that yan ay difference ng mga coefficients ng gases in the reaction. So, take the sum of all the coefficients of gases in the products. Okay? Then, minus, take the sum of all the coefficients of the gases in the reactants. Now, back to my point here. We have here a hypothetical reaction. How do you get the enthalpy of this reaction? Or how do you get the enthalpy of reaction? So, ang gagawin nyo lang is you can obtain the enthalpy of the reaction by using what we call enthalpies of formation. So, ibig sabihin, yung delta H natin is equal to this. Using this hypothetical reaction, so magiging take the sum of the enthalpies of the product. So, meron kang enthalpy of formation ni product C plus enthalpy of formation ni product D. Of course, you have to multiply each with their coefficient. Minus yung enthalpy of formation ni A plus the enthalpy of formation ni B. Of course, the enthalpies are in the standard state. Okay, so that's your thermochemistry. That's how you actually calculate the enthalpy of reaction, kung ano man na reaction yan, from the enthalpies of formation ng mga reactants. So, kailangan meron kayong table of enthalpies of formation. Okay? So, paano makukuha yung mga values ni enthalpies of formation? Nasa table po yan sa mga libro. Now, there are substances that have zero enthalpy of formation. So, yung enthalpy of formation will be zero for what? For which substances? So, example, si hydrogen gas, oxygen gas, si carbon in its graphite form. Now, anong napapansin ninyo sa mga substance na to? There are probably more dito sa listahan na yan, but I have here just a few examples. So, kung mapapansin ninyo, yung mga substances na to, these are in their standard states. Okay, ibig sabihin, at a standard temperature and pressure, which is we will use 298 Kelvin and 1 atmosphere. So, at this particular condition, yung hydrogen gas, oxygen gas, tsaka si carbon as graphite, nag-i-exist sila naturally. So, ibig sabihin, walang change involved in their formation. Okay? Standard yung state nila at this particular temperature and pressure. So, therefore, 0 yung kanilang enthalpy of formation. So, if we're going to compare, let's say, bromine as liquid versus bromine as gas, alin dyan yung may non-zero na enthalpy of formation and alin dyan yung zero yung kanyang enthalpy of formation? Now, bromine as liquid, if titignan nyo siya sa periodic table, bromine will be liquid, standard, no? So, ibig sabihin, bromine, liquid, magkakaroon siya ng enthalpy of formation na 0. While this will be non-zero kasi hindi naman yan yung standard form niya at that particular temperature and pressure. Alright? Now, let's have another example involving enthalpy of reaction and formation. So, if we have, let's say, hydrogen gas plus oxygen gas forming water, so this is giving you an enthalpy of reaction. Ano ang matatawag nyo kapag yung hydrogen gas na yan, okay, the same, no? Oxygen gas forming water, pero if you notice, we divided all the coefficients by the coefficient of the product, which is water. Okay? Since meron kang elements forming this compound, ang tatawagin natin dyan is now formation enthalpy. Ibig sabihin, if you have your stoichiometric coefficient as unity dun sa product, so these are the requirements, no? The stoichiometric coefficients or coefficient of the product should be equal to 1. And also, there shall be only one product. Okay? So, ito yung mga requirement para matawag mo siyang enthalpy of formation. Now, yung enthalpy of formation ni water, okay, which is this, okay, is equal to minus 285.8 kilojoule per mole. So, how do we exactly determine the enthalpy of reaction? So again, kung ito yung consider nating reaction, the enthalpy of reaction will be what? Products minus reactants. So 2 times the enthalpy of formation of water minus 285.8, okay, minus the sum ng mga enthalpies of formation ni hydrogen gas and oxygen gas. However, their value, kung maaalala ninyo, 0 sila. So therefore, the enthalpy of reaction will be equal to negative 571.6 kilojoules per mole. And it makes sense, right? Kasi if you take a look at the equations, yung first equation is just twice in terms of coefficient nung second equation.